The first thing you lose is not your heartbeat, not even your thoughts, but the invisible weight that has held you together since before you could speak. Imagine a lone figure standing on gray stone under a white, merciless sun. The ground is dusted with fine ash, every footprint sharp, every shadow a knife cut of pure black. Above, there is no blue, no clouds, only the raw glare of a star, and the empty dark that begins just beyond a thin layer of glass. Inside the helmet, it feels almost ordinary. Warm breath moves in and out. A soft hiss follows each exhale. Numbers blink on a visor, measuring pressure, temperature, oxygen. Yet the body inside relaxes the same way it does on a quiet walk at home. Outside that shell, there might be searing heat or numbing cold, toxic gas or no air at all. This is the paradox. Surrounded by worlds that would end life in seconds, a human can still feel bored, mildly annoyed, even drowsy, as long as the tiny artificial earth around them does not fail. Hold your own breath for a moment and notice how quickly comfort begins to slip. Your chest tightens, your throat seems smaller. A faint urge rises that says, breathe now. You live every day at the bottom of an invisible ocean of air, pressed on by the weight of the atmosphere from every side, yet you hardly ever feel it. On Earth, that steady pressure keeps your blood liquid, your lungs working, your skin from swelling. On most other worlds, that helpful pressure is missing, or it is twisted into something that crushes, boils, or tears. In secretive laboratories, engineers test the edges of this comfort. They place people in heavy suits inside steel chambers and slowly lower the pressure while cameras watch every movement. There is a point where the air becomes so thin that saliva does not behave like liquid anymore. It begins to hiss and form tiny bubbles on the tongue. Eyes swell. Thoughts blur. At its core, the human body is a warm, wet vessel that only holds its shape because the surrounding air agrees to push back with just the right force. Now ask yourself a simple question. What if we take that vessel, that precise balance of blood, air, and pressure, and drop it onto every planet in the solar system? On which world would you die first? On which world might you last a handful of minutes? Is there any place at all where you could step outside your shell and feel the air on your face without paying for that sensation with your life? If so many planets look beautiful through a telescope, why do so few permit even a single unprotected breath? Look closer at our immediate neighbors and the puzzle deepens. One world orbits close to the sun, its day side baked to glowing heat, its night side locked in deep cold. Another orbits farther out, wrapped in bright clouds. Common sense whispers that the nearer world must be the hotter one. Yet it is the distant, clouded planet that becomes a true furnace. Under those pale clouds, the air grows thick, presses down harder than the deepest ocean trench, and traps heat so well that metal would soften and run. Moving away from the sun, you fall into a worse fire. Beyond them waits a small red world, the one that has filled so many dreams of future colonies and wide-open valleys under a pink sky. From orbit, it looks calm, almost gentle, carved by canyons and dust storms rather than oceans. But for a bare human body, that sky is almost as lethal as pure vacuum. The air is too thin to press your fluids down, too cold to feel safe, and made mostly of gas you cannot use. It cannot keep warmth near the surface, yet it also cannot hold your blood where it belongs. Farther from the sun, giant planets loom in darkness, wrapped in bands of cloud and storms older than human history. They do not offer a solid surface on which to stand. Instead, they have layers upon layers of gas that grow heavier and denser as you descend. To fall into these skies is not to skydive, but to dive. The deeper you go, the more the gas around you feels like water, then like something even heavier, until the pressure turns bones and metal alike into things that can fold. Past those giants lie pale blue worlds that catch the last thin sunlight, From afar, they look soft, their colors like calm seas or distant lakes at twilight. Yet the air there can move at speeds so high that sound cannot keep up. Imagine wind that does not caress, but scrapes. Driven by that wind, grains of ice and dust slam into anything in their path. A protective suit, which seems solid and trustworthy on Earth, would be tested there the way a leaf is tested in a sandstorm. Everywhere we look, the universe offers a different way to say no to a human body. Too hot or too cold, too much pressure or almost none, air that burns, or air that passes straight through your lungs without leaving a trace of oxygen behind. These are not gentle refusals. They are abrupt, often silent, usually impossible to negotiate, in a few seconds to a few minutes. The careful arrangement of liquid, gas, and tissue that you call yourself can be undone. So here is the larger question hiding inside all these scenes. If almost every nearby world kills you in moments, how did you end up on the one that does not? Are you simply lucky to be here? Or is there something deeper about the way life and environment choose each other? What must be true about pressure, temperature, light, and chemistry for a single breath to be taken and given back, again and again, over the span of a lifetime? How narrow is that window, and how easily could it close? We are going to treat a single breath as a measuring device. In this journey, we will carry one fragile lungful of air in imagination from world to world. On each planet, we will ask the same questions. How long does the breath remain inside a conscious person? What fails first? Air, blood, bone, or thought? Does the killer announce itself as blazing heat and roaring wind, or does it slip in quietly as a drop in pressure or a missing gas you never see? As we move outward from the sun, the rules will keep changing. You will find that distance alone does not keep you safe, nor does a lovely color in the sky, nor does the promise of rock beneath your boots. Instead, survival is written in invisible numbers, in the balance between gravity and gas, between the light that arrives from above and the heat that escapes below. By watching what destroys the human body on other worlds, we can understand what preserves it here at home. If this journey through hostile worlds speaks to you, like and subscribe to the Quiet Universe channel. At first glance, they are opposites, one bare and airless, the other smothered in clouds. Yet Mercury and Venus are twins in a deeper sense, two ends of the same experiment in heat and pressure. To step onto either of them would be to discover how thin the line of survival really is. Mercury is close enough to the sun that daylight there is almost a weapon. The sky is black even at noon, because the planet has no atmosphere to scatter light, but the sunlight itself falls 10 times stronger than it does on Earth. The ground shines silver gray, smooth in some places, torn by impact craters in others. Shadows are sharp as blades. When the sun rises, the temperature rockets upward to near 430 degrees Celsius, hot enough to melt lead. When it sets, the same surface plummets to minus 170. There is no air to store warmth, no clouds to soften the cycle. A single rock can hold day and night in its two halves, glowing on one side, rimed with frost on the other. A human there would not burn instantly, but would fail by degrees. Within seconds, the suit's cooling system would fight a losing battle against the radiation. Without protection, eyes would dry and crack, and the fluid in the mouth would evaporate. Breath itself would become useless, because there is no air to inhale, only vacuum. The difference between life and silence is the thin membrane of a visor. Inside the helmet, the lungs try to move air that is no longer there. Outside, light pounds down like a hammer made of heat. What saves Mercury from total chaos is motion. The planet spins slowly, taking 59 Earth days to turn once, but its orbit carries it fast enough that dawn and dusk overlap in strange ways. Between the blistering day and the frozen night lies a thin zone where sunlight comes at a slant. Not too fierce, not too faint. Some scientists call it the Terminator line. a corridor of gray light where temperatures hover near what metal tools could tolerate. If a human ever stood there, perhaps in a small shelter sunk into the dust, they might see the sun rising in slow motion, never climbing higher than the horizon. Even there, though, radiation would stream through space, invisible and lethal. Mercury offers balance for a moment, then snatches it away. Step 1. Orbit farther, and you find a world that looks all gentle from afar. Venus glows pale yellow, almost serene, and its clouds reflect sunlight so well that it became the brightest planet in the sky. To early observers, it seemed a twin of Earth, a place that might hold oceans and rain. The truth is the opposite. Beneath those clouds lies an atmosphere 90 times thicker than ours, made mostly of carbon dioxide, with traces of sulfuric acid that fall as corrosive mist. Temperatures at the surface reach nearly 470 degrees Celsius and stay there constantly, day and night, pole to pole. No sunrise cools the ground. No sunset brings relief. Imagine standing on the surface of Venus. The sky would not be visible, only a golden haze pressing from all directions. The air would crush you before it burned you. At that pressure, every joint of a spacesuit becomes an iron lung straining outward. Sound would travel faster than on Earth, but speech would be muffled by the thickness of gas. Heat leaks through every layer of material, turning metal to wax and circuits to dust. Even probes designed to survive extreme conditions have lasted only a few hours before melting. It is not the nearness to the sun that cooks Venus. It is the trap it built for its own light. Sunlight enters easily, warms the ground, but cannot escape through the heavy gases. The planet has built a mirror around itself that keeps every photon captive. This is the paradox that links the two worlds. Mercury is closer to the sun, yet Venus is hotter. One is exposed to the vacuum of space, the other buried in air so thick that it behaves like liquid. Both prove that distance alone cannot tell you what is safe. It is the presence or absence of atmosphere, and the chemistry within it, that decides whether heat can leave or must stay. A thin air lets energy leak away too fast. A dense one locks it in until the planet suffocates under its own warmth. Think of it like this. A fire can kill you in two ways. It can burn you from outside, or it can smother you from within. Mercury is the first, a blaze that strips protection until the body fails from radiation and heat loss. Venus is the second, a furnace that hides behind soft clouds and ends everything through pressure and suffocation. Between these extremes lies the narrow band of temperature and air that we call comfort, and Earth occupies that fragile middle. If we could watch from above, we would see Mercury as a mirror and Venus as a torch. The first throws sunlight back into space, cold and bright. The second glows with its own trapped heat, an ember that never cools. For an astronaut drifting between them, it would feel as though one side of the solar system shone with reflected silver and the other with burning gold. Both kinds of light are deadly, one because it gives too much, the other because it never lets go. A human presence on either world is nearly unthinkable, yet they teach a lesson about balance. Remove too much air and life freezes. Add too much and it suffocates. Tilt a planet slightly one way and it becomes a frozen rock. Tilt it the other and it becomes a boiling cauldron. Our home world floats in the narrow space between those tilts. A coincidence that feels almost deliberate. When we call Earth a habitable zone, we are really describing a cosmic accident that managed to avoid both fires. So what would a single breath do on these worlds? On Mercury, it would spill into nothing, expanding and cooling until it was gone. On Venus, it would be crushed, absorbed, and turned into part of the choking air. A breath has meaning only where it can move freely between inhaling and exhaling, only where it meets resistance that does not destroy it. That delicate dance is the definition of life. When the first spacecraft sent images back from these worlds, the pictures did not show monsters or alien ruins, only landscapes ruled by simple physics. Yet in those barren surfaces, we saw our own fragility reflected. We realized that the air around us, the one we ignore every moment of our lives, is a rare treasure that most of the universe cannot afford. But what if there is a place that kills not through fire or pressure, but through absence, a world where silence itself becomes the executioner? Mars is often called the most Earth-like of all the other worlds, and from orbit that seems true. Its valleys resemble dried riverbeds, its poles wear white caps, and its red plains stretch like deserts under a pale sky. But the likeness ends at the surface. Step onto that soil, and every sense begins to fail. The sky glows orange because dust floats high above, scattering sunlight weakly through an atmosphere thinner than the air atop Earth's highest mountain. It is a sky that looks alive, yet offers almost nothing you can use. A human standing there without protection would meet a death that is neither violent nor immediate, a slow failure hidden inside the word suffocation. The air is about 1% of Earth's pressure, mostly carbon dioxide, too thin to hold warmth and too weak to keep body fluids stable. You would not burst, as old fiction claims, but the water in your lungs and mouth would begin to boil at body temperature. Not a roaring boil, but a silent blooming of bubbles under the skin, in the eyes, and along the tongue. You would lose consciousness in less than 20 seconds. It is a quiet death, gentle in sound but absolute in result. The first explorers learned this not from walking there, but from tests done in vacuum chambers. When pressure drops below a certain threshold, the balance between air and body collapses. Saliva sizzles. Blood begins to deoxygenate, and the reflex to inhale becomes useless. The heart still beats for a moment, but the brain can no longer interpret its rhythm. The body that once moved through thick, comfortable air now drifts in a near void, surrounded by wind too thin to make a sound. The Martian wind is strange. It can whip dust into planet-sized storms visible from space, yet it cannot move a feather. There is not enough air to carry force, only enough to lift powder and suspend it for weeks. A storm can wrap the entire planet in haze, dimming sunlight until even solar panels fall silent. For a machine, that is an inconvenience. For a person, it is the end of warmth and light. Temperatures plunge to -80 degrees Celsius, and the thin air cannot insulate anything. Heat leaks away faster than you can replace it. Simply put, Mars is a freezer, running in slow motion, powered by emptiness. The ground absorbs sunlight during the day, but loses it as soon as darkness comes. Nights are long and deadly. Frost forms not from humidity, but from carbon dioxide itself, freezing into white crystals that coat the dust. At dawn, those crystals sublimate directly into gas, feeding a short-lived wind that whispers across the plains. The sound is like the sigh of a dying world, too faint to be heard through a helmet, too constant to stop. Yet, there is a deceptive beauty in that silence. Imagine standing inside a transparent dome, watching the sun as a small orange disk moving through thin haze. The horizon glows in soft pastel shades, peach fading into violet, while shadows stretch for kilometers. It feels calm, almost sacred. This stillness seduces the imagination. It promises peace while hiding a perfect vacuum's cruelty. The quiet on Mars is not the peace of a calm morning. It is the quiet of a missing heartbeat. Scientists dream of making Mars more like Earth, of thickening its air by releasing gases from rocks and ice. The idea is bold, but even the most optimistic estimates show that it would take centuries to produce a breathable atmosphere. For now, survival depends entirely on technology pressure suits, sealed habitats, recycled air. Every breath taken there must be paid for with energy, materials, and vigilance. Forget to seal one hatch, one glove, and the world outside will reclaim you in minutes. At its core, life is a conversation between body and air. On Earth, that conversation is constant and effortless. On Mars, it is interrupted every second. The lungs can fill, but not feed. The heart can pump, but not deliver. Even if you brought a tank of oxygen, the pressure around you would not hold it in your blood properly. Breathing there is like speaking into a void, words vanishing before they reach another ear. Some experiments suggest that certain microbes could endure the cold and thin air by slowing down almost to stillness. They would not grow or thrive, only persist. If they can do it, perhaps one day humans might tubal through technology that mimics their patience. But for now, Mars remains a world of pauses, a place where everything that moves must fight against the tendency to stop. To put it another way, Mars is a stage set for motion that never happens. Its riverbeds wait for rivers, its canyons wait for echo, and its air waits for breath. Each day that the sun rises, it paints the same soft colors over land that does not change. Every sunset promises the same cold that follows. Time there feels circular, as though the planet itself has forgotten how to move forward. For those who imagine walking there, the danger lies not only in the physics, but in the psychology. A person who hears nothing and feels no air might forget how to measure their own presence. Without wind or sound, there is no external rhythm to mark the passage of seconds. The heartbeat becomes the only clock. Lose awareness of it, and the world seems to dissolve around you. Mars teaches that silence can be as lethal as heat, and that emptiness can feel heavier than any weight. In this silence, even a spark becomes sacred. The flicker of electricity in a life support unit, the click of valves releasing stored oxygen, the faint hum of a generator, all are signs of defiance against the void. These tiny sounds would mean hope, proof that something still breathes under a sky that does not care. On this world, death is not an explosion but a fading. The lungs do not shatter. They empty. The eyes do not burst. They glaze. The wind does not scream. It whispers your last exhale back into the red dust. If Mercury and Venus kill through fire, Mars kills through forgetting. It lets you drift into the space between breaths, where the difference between alive and gone is measured in seconds of awareness. What matters here is that we finally see how little stands between presence and absence. The human body, designed for one atmosphere and one pressure, finds none of them here. Mars reminds us that even silence has weight, and that survival is nothing more than holding on to sound for as long as possible. But what if we leave the solid ground behind and fall into worlds where air itself becomes liquid, where gravity does not let you stand still, but pulls you deeper with every second? Beyond the calm emptiness of Mars lies a frontier that no human has ever touched. Jupiter and Saturn are worlds without surfaces, titans of gas that swallow the light of the sun and return it in flashes of storm and lightning. To visit them is not to land but to fall, endlessly, through skies that grow thicker, hotter, and heavier until matter itself begins to change its meaning. Imagine approaching Jupiter first, a planet so large that all the others could fit inside it with room to spare. Its upper clouds swirl in stripes of white, tan, and rust. Endless rivers of storm stretched around the circumference of the planet. The famous Great Red Spot, a storm twice as wide as Earth, has been spinning for centuries. To hover above it is to look into a wound in the atmosphere, a spiral of wind that never finds rest. At first, you might see the sunlight glinting on the tops of ammonia clouds, soft as smoke. But as you descend, that softness hardens into pressure. The air there is not truly air. It begins as hydrogen and helium, gases that on Earth float and make balloons rise. Yet under Jupiter's gravity, those gases pile upon themselves until the weight becomes unbearable. Every 10 kilometers downward, the pressure doubles, triples, multiplies beyond human experience. A human body, even inside the strongest craft, would feel the structure around them groan and flex. There would be no warning when the walls began to fold inward. The atmosphere itself becomes the crushing hand. There is no surface to reach, only layers where gas thickens into liquid. Hydrogen becomes a strange fluid, metallic and conductive, able to carry electricity like molten iron. Lightning bolts thousands of kilometers long crackle through this ocean of cloud, illuminating the deep like underwater volcanoes. If you could somehow survive the pressure, you would see light in colors. Earth's sky never shows violet, copper, turquoise, flashes that paint storms that never sleep. But there is no survival here. The deeper you fall, the less likely atoms can stay in their usual forms. To put it simply, Jupiter is a star that never ignited. It has mass enough to crush, but not enough to burn. The heat it radiates comes from gravity squeezing it inward, from energy trapped since its birth. Entering its atmosphere is like diving into an unfinished sun, one that holds you but never lets you return. A spacecraft falling inward would be pulled faster and faster, its instruments failing one by one as the outside turns from gas to fluid and finally to metallic mist. The concept of sky ends, replaced by density without limit. Yet Jupiter's violence is not only in depth. Around it whirl dozens of moons, some covered in ice, some spewing geysers of vapor into space. The planet's magnetic field is so strong that it traps radiation belts deadly enough to fry electronics within hours. Even before reaching the clouds, invisible storms of charged particles would batter a human traveler. Radiation here is not a distant glow. It is an invisible hailstorm of energy. A minute in that field would deliver more dose than a lifetime on Earth. Then there is Saturn, the quieter twin, beautiful and deceptive. Its rings shine like a halo, delicate from afar, but made of shards of ice and rock spinning at enormous speeds. Each fragment is a bullet, orbiting so fast that a collision releases energy enough to melt both objects into vapor. To pass through those rings would be to drift through a silent battlefield where every piece of debris is lethal. They look solid, but they are a million narrow rivers crossing one another at impossible angles. Between them lie gaps carved by tiny moons, each moon shepherding particles with its gravity like a conductor leading an orchestra of ice. Descending into Saturn's atmosphere begins gently, almost tenderly. The top clouds are pale gold, marked by soft bands and thin shadows. Light filters down as though through gauze. For a few moments, it might seem peaceful, even inviting, but beneath that beauty lies a slow trap. The deeper layers are cooler than Jupiter's, but still vast, and the same rule applies: pressure doubles every few kilometers. Gases thicken, and the weight grows. What began as a fall through mist becomes a dive into syrup, then into liquid. The boundary between air and ocean disappears. In the middle layers, winds blow faster than the speed of sound on Earth. They circle the planet in neat parallel bands, each with its own rhythm. The upper clouds drift east, while the lower ones stream west. A counterpoint of motion that tears apart anything caught between them. Even robotic probes that tried to measure the atmosphere reported turbulence that shook them like leaves in a hurricane. These are not storms in air as we know it. They are rivers of fluid hydrogen crashing into each other under planetary weight. Saturn's core, if it exists in any stable sense, is buried tens of thousands of kilometers below the visible clouds. It might be a ball of rock and metal surrounded by layers of ice and liquid gas. Temperatures could reach 10,000 degrees Celsius. Pressures millions of times greater than Earth's sea level. No probe has seen it, and perhaps none ever will. The planet guards its depths with gravity alone, a wall no engine can climb out of once crossed. At its heart, Saturn hums. Scientists have recorded vibrations within its rings, ripples caused by oscillations deep in the planet itself. The entire world seems to breathe in slow pulses, like a vast instrument playing a note too low for the ear. Standing near that planet, if such standing were possible, would feel like being inside the sound of thunder that never stops. For a human, the difference between Jupiter and Saturn is one of tempo. Jupiter kills swiftly, with weight and radiation. Saturn kills slowly, with depth and motion. Both teach the same rule in worlds made mostly of gas. gravity is the enemy. It never rests, never yields, and always pulls toward an unreachable center. Think of it like this: if you fell from a ship into Jupiter's clouds, you would not land but dissolve. Each kilometer would add pressure until the molecules of your body could no longer resist, turning you into part of the planet itself. On Saturn, you would fall more gently, drawn through layers that blur color and sound, until even gravity's pull felt like a kind of silence. You would not be crushed in an instant, but absorbed into the slow music of the atmosphere. The lesson is not only about death, it is about scale. These worlds remind us that human proportions mean nothing beyond Earth. What we call solid or fluid, fast or slow, hot or cold, are only local definitions. Out here, gas can act like metal, wind can act like rock, and clouds can be as deadly as walls of iron. The sky itself becomes an ocean, and the fall never ends. In every direction around these planets, the balance of forces is so delicate that small moons carve precise lanes through the rings, while storms hundreds of kilometers wide spin without drifting. It is a chaos that obeys order, a music of gravity and motion far beyond any human sense of rhythm. If Mars was the silence of suffocation, Jupiter and Saturn are the roar of pressure. Both destroy, but one does it with emptiness, the other with weight. To descend into such skies is to surrender identity. There is no up or down, no edge to cross, no ground to reach. The only certainty is compression, the slow erasure of form by forces too vast to resist. Perhaps that is why we study them, to know how far the idea of structure can stretch before it gives way to chaos. But if pressure can crush, and wind can tear, what happens when air itself becomes faster than sound? When cold learns to cut like metal instead of freezing it? The outer giants drift in twilight, far from the sun, pale and slow in their movement. Uranus and Neptune are the last sentinels of our planetary system, where sunlight arrives as a faint whisper and heat is almost forgotten. To the eye, they look calm, serene, wrapped in blue and turquoise light. But their calm hides motion so fierce that it erases the meaning of air. Here, the wind is not something you feel. It is something that destroys. Uranus spins on its side, tilted so far that its poles point almost toward the sun. Its seasons last decades. One hemisphere soaked in long summer, while the other freezes in endless night. If you could hover above its clouds, you would see bands of faint color, subtle shades of green and blue, moving slowly across a globe that seems asleep. Yet beneath that stillness, the air flows faster than any jet stream on Earth, circling the planet at hundreds of meters per second. A storm here would move so quietly, with air so thin and cold, that you would never hear it coming. A human presence could not exist here. Temperatures fall near -200 degrees Celsius. The atmosphere is mostly hydrogen, helium, and methane, all gases that, under these conditions, behave like liquid ice. Any exposed metal would become brittle as glass. Any plastic would shatter at a touch. The cold is not a sensation. It is a weapon. It draws heat from you faster than fire gives it. A single breath would freeze the moisture in your lungs before you could exhale it. In such a place, death is not burning or crushing, but crystallizing. Simply put, Uranus is the deep freezer of the solar system. It receives so little sunlight that its interior heat barely escapes. Strangely, it gives off less energy than it receives, as though it has stopped breathing. Some scientists think a cataclysm in its distant past knocked it over and sealed part of its warmth beneath thick layers of gas. Whatever the cause, the result is eerie. This is a planet that glows faintly, but gives almost nothing back. Light arrives, but heat does not return. The world itself has fallen asleep. Neptune, however, is wide awake, slightly smaller, but far more active. It is the kingdom of the wind. Its atmosphere looks smooth from far away, an even blue disk against the stars. Yet up close, it swirls with the fastest gusts in the solar system. Winds can reach more than 2,000 kilometers per hour, faster than the speed of sound on Earth. These are not breezes. They are rivers of moving gas that sweep around the planet in steady, relentless loops. Any object caught within them would be shredded before it could even tumble. To the human eye, the contrast is striking. Uranus glows soft and diffuse, a lantern seen through fog. Neptune is darker, deeper, like cobalt glass lit from within. Its storms, captured in brief glimpses by passing spacecraft, appear as ovals of shadow sliding through blue haze. Lightning flashes silently across them, bright enough to be seen from space. Each strike releases more energy than a terrestrial thunderstorm. Yet even this violence is muffled, absorbed by the weightless gas around it. Sound here cannot travel far. Every explosion becomes a whisper. In everyday language, these worlds are what happens when motion meets silence. They are proof that speed and cold can coexist, that air can move faster than sound without producing noise. That temperature is not the only measure of danger. Where Jupiter crushed and Saturn sang, Uranus and Neptune slice. Their danger lies in the way the cold binds itself to movement, turning each gust into a blade. A suit designed for heat or pressure would fail instantly. The seams would crack, the joints would freeze, and the wind would pick them apart grain by grain. Imagine a human figure stepping out of a craft above Neptune's cloud tops. The horizon is a dim blue arc. The sun is no larger than a pin, barely bright enough to cast a shadow. The first blast of air would not feel like wind. It would feel like static, a vibration of countless particles brushing against the suit with the precision of sandpaper. Then, almost invisibly, the suit would begin to frost, its layers stiffening as the wind scours it. Instruments would register the cold not as a temperature but as a loss of energy, a number racing towards zero. Within minutes, everything mechanical would cease. The person inside would not hear the tearing, because sound cannot move faster than the storm doing the tearing. For Neptune, energy comes from within. Its core still radiates heat left over from formation, driving convection that keeps its winds alive. Uranus, colder and quieter, lacks this internal furnace. The two planets are a study in contrast, one sleeping, one spinning furiously. Both hostile in ways that make Mercury's fire or Venus's pressure seem almost gentle. Fire gives warning. Wind does not. You never see the blade until it has already cut. Why it matters is simple. When you see the calm blue of Neptune, you are not looking at peace. You are looking at speed and cold perfected together, a world where molecules move so fast and yet so quietly that the boundary between gas and liquid begins to vanish. It reminds us that beauty can hide power, and that stillness in space often means distance, not safety. The physics of these planets border on poetry. Methane gas, normally colorless, absorbs red light and reflects blue, painting both worlds with a hue that no artist could reproduce faithfully. Beneath that color lies darkness and distance beyond imagination. Sunlight takes 4 hours to reach Neptune, and by then it has weakened to a pale echo. The planet glows faintly on its own, illuminated by the violence of its storms. It is a light born of movement, not warmth. To put it another way, Uranus and Neptune are the universe's experiment in endurance. They show how a planet can remain alive long after its warmth should have died. Their winds never rest. Their cold never deepens enough to stop the motion. It is as if energy itself has forgotten how to be still. These worlds are frozen hurricanes that last forever. A human watching them from a distance might feel both awe and grief. Awe, because such perfection in extremes feels like art. Grief, because it makes Earth seem impossibly fragile. Here, every drop of warmth, every slow breeze, every color of sunset exists within a perfect range that keeps us alive. There, a few degrees colder or a few meters per second faster, and all possibility of life disappears. In the far reaches where these giants circle, time slows. Seasons stretch into decades, orbits into centuries. The wind never stops. The storms never sleep, and the cold never forgives. To stand near them, even in thought, is to sense the edge of what nature allows. They are the final test of motion and stillness, the boundary between what the sun can reach and what it cannot. But after the cold and the wind, after every death imagined in heat, pressure, and silence, one question remains. Why does one small planet, back in the inner light, defy all these rules and let a single breath stay whole? When you return from the cold and the wind, when the memory of boiling skies and frozen storms has faded, the simplest sound in the universe becomes holy again. It is the sound of breathing. Air moves, chest rises, pressure inside and out agrees once more. The act is so ordinary that it feels invisible. Yet after everything the solar system has shown, it becomes the rarest sound we know. Every planet we have visited in thought refused that sound. On Mercury, light scorched it away. On Venus, pressure crushed it flat. On Mars, it drifted into nothing. In the gas giants, it dissolved in weight. And on the ice worlds, it shattered in the wind. Only here, on Earth, does breath form a rhythm that endures. The air presses softly, neither too heavy nor too thin. It pushes against skin with the same insistence that the body pushes back. Between those two forces, life negotiates its fragile treaty. In plain terms, to live on Earth is to exist inside a balance of contradictions. Gravity pulls you down, air holds you up, heat drives you forward, and cold slows you just enough to rest. You stand between extremes without feeling the pressure of either. The silence of space and the roar of stars are both muted by the thin film of atmosphere that hugs this planet like a protective hand. It is a miracle so common that language struggles to describe it without sounding naive. Consider this when you inhale. The oxygen entering your lungs was born in the core of a long-dead star. Every breath is ancient, recycled from explosions that happened before Earth itself existed. You are not borrowing air. You are borrowing time. The atoms you exhale will drift, mix, and someday be inhaled by another creature who will never know your name. Breathing is not only survival, it is participation in a continuous exchange older than memory. From the outer worlds, we learned what happens when that exchange breaks. Pressure too high crushes individuality. Pressure too low erases it. Venus smothers. Mars forgets. Between those failures lies the only narrow path where identity can persist. Perhaps that is the deeper lesson of the solar system, that life is not a right, but a coincidence. A precise alignment between what wants to expand and what insists on containing it. The universe does not forbid life, but it does not make room for it easily. We call this thin margin home. Inside it, water stays liquid, sound travels, and color exists. Outside it, all becomes either solid or vapor, silence or noise, too much or too little. From this middle ground, we look outward and imagine adaptation, survival, colonization. Yet perhaps the point is not to escape, but to understand what has already been given. The gentle one atmosphere that hugs our bodies is not weakness. It is the measure of how perfectly tuned this world is for our kind of motion. At its core, Earth is a breathing machine powered by sunlight. Air flows over mountains and seas, warmed by day, cooled by night. Every leaf, every wave, every creature becomes part of the same pulse. It is this shared rhythm that keeps chaos at bay. Remove it, and the planet would fall silent in the same way Mars already has. The continuity of that rhythm may be the most profound phenomenon we know, yet we treat it as background noise. There is another truth that rises from this journey. The farther we look into space, the more it feels like we are looking back at ourselves. Each world shows what we could have been if one element, one orbit, one tilt had gone differently. Fire, pressure, vacuum, wind, all are lessons in boundaries. Life is not written into the laws of physics. It is carved out of their compromises. To live is to be balanced on the edge between collapse and expansion, between too much and too little. The same physics that can crush a planet also built the molecules of your blood. The same radiation that scorches Mercury warms the seas. The same gravity that traps storms on Jupiter holds your body to the ground. Everything destructive is also creative when measured on the right scale. The universe has no interest in safety or danger, only in the exchange of energy. We, by breathing, make that exchange personal. Think of it like this. The sky you see is the thinnest film of gas standing between you and a vacuum colder than any winter. You cannot feel it pressing, yet it is always there, invisible and loyal. Every sunrise renews the contract. Every storm tests it. Every calm evening proves it has held. That is the treaty of air and light that allows everything to exist. Break that treaty, and you return to the silence of the other worlds. We live by a narrow treaty of air and light. The line sounds like poetry, but it is also fact. It defines what it means to be human, to stand under a sky that neither crushes nor vanishes. It is the quiet agreement between the earth and everything it carries. Perhaps one day we will find another world that signs the same treaty, a second place where breath can move freely. But even if we do, the first breath taken there will still belong to this one. As you breathe now, remember that nothing in the cosmos guarantees this motion. It happens because billions of factors happen to align, because the sun gives just enough, because the atmosphere stays just thick enough, because the planet spins at the right speed. Existence is not a gift. It is a balance you must maintain with every inhale and exhale. That knowledge should make each breath heavier, yet it also makes it sacred. The quiet of space is always waiting. The cold of Neptune, the storms of Jupiter, the silence of Mars. They do not end when we turn our gaze away. They continue, indifferent, beautiful, and lethal. Between them, one small planet keeps time by breathing. We are its lungs, its memory, its temporary voice. So when you look at the sky tonight and see the thin blue line that separates light from dark, ask yourself one question. How long will this treaty hold? And what will we do to keep it signed?